You are welcome to my class. And today I am here to discuss a new chapter. And today I am going to discuss a new concept and new chapter for the students of class 10. Okay. My today's discussion will be on the chapter Factorization of Polynomial, Remainder and Factor Theorem. Okay. So first you have to know what is polynomial. Okay. So first you have to know this part, that what is polynomial. Polynomial means first of all, polynomial is an algebraic expression. Okay, if in an algebraic expression which are having more than one term, and each of the power of the variable should be non-negative. Okay, you have to keep in your mind two information, that an algebraic expression which are having more than one terms and each of the power of the variable will be more than one. Okay, I am considering an example, then I hope you will get the idea that what is algebraic expression. Suppose 2x square plus 3x plus 5. Okay, obviously this is an algebraic expression since here a variable is present here, x, and this is polynomial also. Why? More than two terms are there and each of the power are non-negative. Non-negative means it can't be negative. Okay, so this is an example of algebraic expression. This is an example of polynomial. Okay, if I am considering one more algebraic expression, suppose 2x to the power 7 plus 5x square minus 3x to the power minus 4 plus 3. Then now my question is it a polynomial? The first criteria satisfied here, that more than one term is there, but here all the power of the variables should be non-negative. But see, in this term the power is minus 4, so this is not a polynomial. Okay, why? Since negative power is present here. Negative power of the variable. Is there. Okay, so today our discussion will be on the chapter Factorization. Okay, what is the definition of polynomial? Okay, an algebraic expression of the form a naught x to the power n plus a1 x to the power n minus 1 a2 x to the power n minus 2 plus dot 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 n, where a0 a1 a2 dot 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 n, these are constant, that means some numbers, and a0 not equals to 0. If a0 not equals to 0, then we can say that the expression is of degree n. I have discussed this part. Okay, so the chapter name is Factorization of Polynomial, okay, and Remainder Factor Theorem. Up to 3 degree polynomial are in your syllabus, and now I am going to discuss about factor theorem. Okay, but before my main discussion about factor theorem, I would like to recall the division algorithm, which is the very important part and which need to explain about factor theorem. Okay, so what is division algorithm? Okay, I am explaining division algorithm by considering an example. Okay, what is division algorithms? First, if we consider a division process, suppose 35, if we divide by 4, okay, then 4 8 ja 32, and remainder is 3. Okay, here the number which is in this place is called, I hope all of you know about it, that this number is called dividend. Okay, and the number which is in this place, this is called divisor. Okay, this is called quotient, and this rest part is called remainder. Okay, so in a division process there are 4 type of things. One is divisor, dividend, quotient and remainder. Okay, so now question arises that what is division algorithm? Actually, division algorithm means the relation among these 4. Relation among this divisor, dividend, quotient and remainder. So is there any relation among these 4? So to make the relation, I am considering a story. Okay, suppose for this division process we can make a story. Okay, suppose this is you and you have 35 total chocolates, 35 total chocolates in your pocket. Okay, and I told you to distribute these 35 chocolates among 4 students. So suppose this is 4 students. This is first student, second student, third student, and this is fourth student. I told you to distribute these 35 chocolates among 4 students equally. Okay, then if you try to distribute these 35 chocolates among these 4 students, then each of the students will get 8 chocolates. Okay, so since I told you to divide these chocolates equally, so each of the students get 8 chocolates. 8 chocolates. Okay, and the chocolate left in your pocket will be 3. So this is the story. This is the left in your pocket. So we can, I have associated a story with this division process. With this division. So I explaining again that suppose you have 35 chocolates, and I told you to divide these 35 chocolates among 4 students equally. Then each of the students got 8 chocolates and 3 chocolates left in your pocket. So this 3 is called remainder, and the number of students is our divisor here, and dividend means our total number of chocolates, and quotient means how many chocolates got each of the students. Clear? So hope you get the idea. After that I am asking you a question. Suppose from the concept of previous story, okay, I am asking you a question. Suppose you have some chocolates in your pocket. I have not mentioned here that how many chocolates you are having in your pocket. Okay, some chocolates. So some chocolates in your pocket, and you have distributed the chocolates among suppose 5 students. 1, 2, 3, 4, 5. Okay, you are having some chocolates and you have distributed those chocolates among 5 students, and each of the students got 3 chocolates. Okay, 3 chocolates. And suppose 2 chocolates left in your pocket. 2 chocolates left in your pocket. This chocolate is left in your pocket. Okay, is it clear to you? Suppose you have some chocolates. You have some chocolates and you have distributed those chocolates among 5 students, and each of the student got 3 chocolates, and after distributing all the chocolates, 2 chocolates left in your pocket. If I ask you that how many chocolates did you have in your pocket, then is it possible to answer me? Yeah. Just try to understand, all the chocolates are in this position. See, these are the chocolates and the left. So if we add all these then we will get the total chocolates. So you have distributed among 5 students. So 5 into 3. Here total number of chocolates is this, and left in your pocket is 2. So this is our total number of chocolates. These are total chocolates. Clear? So if we put this concept into a division process, then what? Here number of students is 5, so you have distributed on 5 students, okay, and each of the students got 3 chocolates, and rest in your pocket is 2. So we can calculate the dividend. Is it clear? And this dividend equals to this into this. See, 5 into 3 plus 2. That means divisor. This is called divisor. This is called quotient. And this is remainder. Then we can conclude that dividend equals to divisor into quotient plus remainder. Is it clear? I am writing this part. This is very important. So divisor, dividend equals to divisor into quotient plus remainder. Always you will get the dividend from this relation, and this is the relation among these 4: divisor, dividend, quotient and remainder. And this relation, actually this is an identities. Okay, dividend must be identical with divisor into quotient. Identical means in left hand side and right hand side you will get the same number. Okay, if you multiply divisor into quotient and after that if you add remainder, then the number which we will get, that number must be equals to the dividend. That means identical with dividend. Okay, so this process must be followed by each and every division. Okay, so this is called division algorithm. This relation, I know that all of you knew about it, that dividend equals to divisor into quotient plus remainder. Okay, now if we try to write this algorithm into a statement, then what? Let me discuss one more important thing. Suppose this is 3 and what is some number is there, a. Then here divisor is 3 and dividend is a. Okay, now just guess about the remainder. What are the possibilities for remainder? If we take r as remainder, then is there any possibility that r will be 4? R equals to 4. Is there any possibility then r can take the value of 4? No. If r is here 4, then 4 can't be remainder. Why? Since if we take this as 4, then we can divide one more time by 3. 3 ones are 3. Clear? So r can't be 4. R equals to 3. Is there any possibility that remainder will be 3? No. Why? If r equals to 3, then we can divide one more time. 3 ones are 3 and remainder will come 0. Is it clear? So r not equals to 3 also. R equals to 2, chance is there. R equals to 1, chance is there. R equals to 0, chance is there. So if r is 3, then if divisor is 3, then remainder can take the value 0, 1 or 2. That means remainder must be less than 3. Remainder must be less than 3. So we conclude from here that remainder will be less than divisor, okay, or equals to 3. That means remainder will be 0 less or equals to, remainder can take the value 0, so that's why I am using here less or equals to remainder less than divisor. It is always true. Okay, so I am writing in a statement that, hope you get the idea, this part. Division algorithm. Division algorithm. If B is B divided by A, division algorithm is here, just to better understand, I am writing here that B divided by A, that means B is our dividend, A is our divisor, B divided by A, and Q is the quotient and R is the remainder. Then division algorithm is B equals to, that means dividend equals to divisor into quotient plus remainder. Okay, where now we have to write about R. R is 0 less or equals to R less than A, and R must be integer. Okay, so it will be better if you write in this way. R belongs to I. Okay, so it will be better that is R equals to 0, 1, 2, dot 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 A up to A minus 1. Okay, so this is the division algorithm, and I have discussed this division algorithm on the basis of number system. That means here A, B, Q and R, these all are the numbers. Okay, so I told you that division algorithm always true for every division process expression. Then that time you have added among two algebraic expression, you have subtracted, you have multiplied, and you have also divided of two algebraic expression. So what will be in the concept of algebraic expression? Hope all of you are able to divide two algebraic expression. Okay, so now I am considering example of a division of two algebraic expression. Okay, then you will get the idea. To remind you, I have considered here a division of two algebraic expressions. See, divide x cube minus 2x square plus 3x plus 5 by x minus 2 and find the remainder. Okay, so you have to divide it by x minus 2. Okay, so here this is an algebraic expression and polynomial also, and this is also an algebraic expression and polynomial also. So if we divide it, then what was the process? We have to divide x cube minus 2x square plus 3x plus 5 by x minus 2. The process was just you have to match the first term. Here first term is x cube and here first term is x. Okay, to get x cube, what you have to multiply with x? To get x cube, what you have to multiply with x? Obviously by x square. If you multiply x by x square, then you will get x cube. Your focus should be on only the first term. Okay. So now multiply and put here. So x into this will be x cube, and this is minus 2x square. Wow, very good. Now, according to the division process, we have to subtract here. So when we subtract, then we have to change the sign of the last row. So plus is there, so it will be minus. Minus is there, so it will be plus. And now we have to simplify by considering the new sign. So this is plus x cube, this is minus x cube. So both this plus x cube minus x cube cancel out. Okay. Here minus 2x square, this is plus 2x square. Fortunately, this term also cancel out. So rest term is x 3x plus 5. Now again the same process. To get 3x, we have to get 3x, and by this first term x, by which term you have to multiply with x to get 3x? Obviously by plus 3. Okay, so by 3, then it will be 3x, and 3 to the minus 6. Again change the sign, then it will be minus, it will be plus. Then again 3x cancel out, opposite sign. So this is 6 plus 5, 11. So this complete the division process, and this division process also must satisfy division algorithm. That means dividend must be equals to divisor into quotient plus remainder. Clear? So here x minus 2, if we divide x cube minus 2x square plus 3x plus 5 by x minus 2, then we will get the remainder 11. Now question is it only one way to find out the remainder? If this is the only one way, then the process is very long. We are very fortunate that we can cancel out this term. Okay. So actually in this chapter, remainder and factor theorem, you have to learn about to find out the remainder without division. We will skip this process. Okay, and without this process, we will try to find out the remainder. Okay, and we are going to establish that part, that how to find the remainder without division. Okay, so to discuss the remainder and factor theorem, I have considered an example. Okay, this is a question. We have considered as a question. See, question is, if fx is divided by x minus a, then find the remainder. This is the question. If fx is divided by x minus a, so x minus a is divisor here, and fx is dividend. Okay, and quotient is not given, and you have to find the remainder. Just divisor and dividend is enough to calculate the remainder. Okay, so according to the question, we are given that we are going to divide fx by x minus a. Okay, we don't know what exactly fx is. Okay, so how to calculate that? What would be the remainder? So suppose if x minus fx means a polynomial of x, okay, function of x. This is x minus a. In previous example, we have taken x minus 2. So in the place of a, there was 2. Okay, so if fx is divided by x minus a, we can assume that quotient is suppose qx. Why we have written here qx? Since there the generating divisor will be also a function of x. that means the expression of x. That's why I have written here qx, and remainder is considered as r, capital R. Okay, I'll discuss later that why we have considered here a constant number. Okay, why we have not used here x, I'll discuss later. So to solve it, we have assumed this part and this part. So let q of x is the quotient and r is the remainder. Okay, so clearly this is a division process. Okay, so division algorithm must be satisfied by this. Then by division algorithm, what? Divisor equals to, that means fx equals to divisor into quotient. Here divisor means x minus a and quotient is qx plus r. Is it? Divisor, dividend equals to divisor into quotient plus remainder. What is our target? Our target is to calculate remainder. That means we have to calculate r. Clear? So is there any process to calculate r? See, this is an identity. Actually, these two are identities. Okay, in the case of identities, we can use triple line. Okay, this part and this part basically same thing. Okay, since this part and this part basically same thing, so if we put in both sides x equal to a, then again it is true since this is identical. So if we put x equals to a, then see this side will be f of a equals to, here a minus a, cancel out 0. So 0 into qx means 0 itself plus r. Understood? This is nothing but f of a equals to, we get r. See, f of a equals to r. So remainder will be f of a. Understood? So question can arise that why sir you put here x equals to a. We put here x equals to a to remove this term only. See, if we put here x equals to a, then this term will be 0 and this term will vanishes. Understood? So we get the remainder equals to f of a. So we get the answer that if fx is divided by x minus a, then in the place of find, the remainder is f of a. Remainder is r equals to f of a. Understood? We get the answer. So write down this part, that if fx is divided by x minus a, then remainder is r equals to f of a. Remainder means r equals to f of a, and you have to memorize it. This line. This line you have to memorize, that if fx is divided by x minus a, then remainder is r equals to f. If fx is, you have to memorize it, that if fx is divided by x minus a, then the remainder is r equals to f of a. So this is our conclusion. Now how to solve a problem. Okay, I am considering an example. Suppose the question is find the remainder if x cube plus 2x square minus 3x plus 7 is divided by x minus 1. Okay, so how to solve? Solution. Just apply this line only. Here fx is divided by, so this is our fx divided by x minus a, that is a means our 1. Then remainder is f of a. So directly you can use that here fx equals to x cube plus 2x square minus 3x plus 7. Okay, therefore remainder equals to f of what? In the x minus a, so if we consider x minus a, then we have to put x equals to a. So here x minus 1 is there, so we have to put x equals to 1. You can take into this form also, that x minus 1 equals to 0, therefore x equals to 1. So we have to put x equals to 1. So f of 1, remainder equals to f of 1. So now put here f of 1 means we have to put in both sides x equals to 1. So if you put in the place of x 1, then this is 1 cube. 1 cube means 1. Okay, I am writing here. 2 into 1 square minus 3 into 1 plus 7. Now solve it. 1 plus this is 2 minus 3 plus 7. So 7 to 9, 10, 10 minus 3 means 7. So this is the remainder. So easily we are able to find out the remainder. Hope you got the idea. Understood? Okay, next. See, these all three are our observations. Okay. First we have proved, first one, that if fx is divided by x minus a, then remainder will be r equals to f of a. Okay. See the second one, if fx is divided by x plus a, in the place of x minus a, there is x plus a, then remainder is, I told you that which value you have to put in the place of x, you will get just by considering the divisor equals to 0. Okay, so if you put divisor equals to 0 verbally, that x plus a equals to 0 implies that x equals to minus a. So you have to put x equals to minus a. Okay, so complete this line. If fx is divided by x plus a, then remainder is r equals to f of, in the place of x we have to put minus a, f of minus a. So this complete the second. And third, if fx is divided by x plus b, then remainder is, similarly put divisor equals to 0, roughly x plus b equals to 0, implies that x equals to minus b, implies that x equals to minus of b by a. So you have to put x equals to minus of b by a. So remainder is r equals to f of minus b by a. So this three, and these three are called, known as remainder and factor theorem. Okay, no need to memorize this part. Easily you can get the value of x, that which value you have to put. Clear? So these three you have to memorize, these three result only, and you have to prove the second one and third one also by the similar way, which I have used to prove this one, first one. Okay. Next, what do you mean by factor? What do you mean by factor? Remainder and factor theorem. This was remainder theorem, but factor means when does a number is called factor? Suppose, okay, let me write. Consider a number 24, then a number is said to be a factor of 24 if that number can divide 24. As for example, if we consider 3, then 3 can divide 24. Okay, 3 can divide 24. See, 3 8 is 24. Okay, so 3 can divide 24. That's why 3 is a factor. But 5 can't divide. So 5 is not a factor. Okay, so factor means we can conclude that if the number can divide properly, that means can divide means remainder will come 0. Okay, so we will use this same concept that if x minus a is a factor of fx means that polynomial, then remainder must be 0. Remainder, what is the remainder? If fx is divided by x minus a, remainder must f of a, just I taught you, and this value must be 0. Okay, and same for others too. Factor means always remainder must 0. Clear? So this complete the theory part of this chapter, and in my next video I will discuss some example.
Okay, this is the summary of this chapter, and this summary is on remainder only. Okay, so see the first one. If a polynomial fx is divided by x minus a, then remainder is denoted by r, so remainder will be f of a. Okay, for the second one, if a polynomial fx is divided by x plus a, then remainder will be f of minus a. And third one, if a polynomial fx is divided by ax plus b, then remainder will be f of minus b by a. So no need to memorize this all three, I think. Why? What you have to put in the place of x, you will get by considering in a rough page divisor equals to 0. Okay, see the first one. In the first one, divisor is x minus a, and if you consider x minus a equals to 0 in a rough page, then you will get x equals to a. So that's why, see, in the first one remainder is f of a. That means in the place of x you have to put a. Okay, since x equals to a. See the second one. If a polynomial fx is divided by x plus a, so here divisor is x plus a. So in your rough page, if you take x plus a equals to 0, then from this equation you will get x equals to minus a. That means you have to put in the place of x minus a. That's why, see, remainder is f of minus a. And for the third one, if a polynomial fx is divided by x plus b, so here divisor is x plus b. So what you have to put in the place of x, you will get by considering x plus b equals to 0 in your rough page. So if you consider x plus b equals to 0 in your rough, then x equals to minus b, therefore x equals to minus of b by a. That's why the remainder is f of minus b by a. Understood? And all these summaries you have to keep in your mind, since you need this summary to solve the exercises problem of this chapter. Okay, so I think no need to memorize this part, since I told you a very easy way. Okay, next, this is the summary based on factor. So since here x minus a is a factor, that means you can divide fx by x minus a. You can divide means what? Remainder must 0, and in my previous concept you know about the remainder. So if x minus a is a factor of polynomial fx, then the remainder is f of a, and the remainder value must be 0. Okay, that means in simple word, if the divisor is a factor, then remainder must be 0. So similarly for second and third one. Understood? And this is the table, so that easily you can get all the information about remainder and factor. See, the dividend is fx here. Okay, So if divisor is x minus a, for that case remainder will be f of a, and condition for divisor is a factor is remainder f of a equals to 0. Okay, and second one x plus a. Actually I have written here all the information by a table so that easily you get all the information in a table. Okay, so this complete today's class. Okay,
please subscribe my YouTube channel and press the bell icon so that you get the notification of all updates.